Alright folks, our next test is the albumin, and this one just requires eyes, the urine sample, and a flashlight. There's no equipment really needed besides that. The albumin is actually a measurement of the amount of cellular debris. So what we're going to do, how we read that, is basically we take our pipette that was in our urine and we're going to stir the sample up a little bit. And we're going to take a look at it, and we want to see if we can see any particles in there. And for example, in this specimen, I can see plenty of particles. Now, it almost looks like if you've ever looked through a window or through the light that comes through a window and you see all the dust particles, a lot of times it'll look like that. Sometimes you'll see some large, kind of ugly particles, white things. Sometimes you'll see hairs. They look like hairs in there. Sometimes you won't see hardly anything at all, and that's where your eye needs to get trained to look at the middle of the cup, the center of the cup. And sometimes it's good to put your pipette in the center, and you'll see the little particles going around. Now, I have a good light source looking here right at it. If you want some help, one of the ways is to take a flashlight and to shine it right through. This flashlight is not really working all that well, and again, I have such a good light source that the flashlight doesn't make it any better. But again, you're going to look in there. If you can see, and here is the rules of reading it. If there are particles floating around, but most of the specimen is clear, that is what we call a 4M. Now remember, 4M stands for 4 million. If the test was perfect, and the person's number was perfect, there would be in 1 liter, now you know how big a liter is. This bottle of alcohol, for example, is half a liter. In 2 of these of urine, which also would be as clear as this alcohol or water, if the person had perfect health, you would be able to find only 2 particles that you could see. And each particle represents 20,000 you cannot see. So when you look at something like this, which is probably here about 30 milliliters, you don't even have 100 milliliters, a tenth of a liter, and if you see 15 particles in there, you know it's a 4M. 4M would stand for 4 million, because if there's 15 in here times 20,000, if you were to take 15 times 20,000, you would come up with, let's see what your figure would be. 15 times 20,000 equals 300,000. But remember, that's only a 30 milliliter. So 30 milliliters into 4 million, I'm sorry, not into 4 million, into 1 full liter, that's 1,000 milliliters. 1, 2, 3, so 1,000 divided by 30, that would be 33.33 times 300,000 particles, and you see you've got 10 million in there. So the point is that if you see any particles in here at all, it's going to be a 4M. All right, that's going to be your first reading. And how you would mark that down is simply 4M. And I'm going to mark that on the back like this so you can see that right now. I'll mark it on the back of the card. No, I'm going to mark it on the back of this paper right here. We'll go right through, yes. I'm going to mark it on the back of... Mark it right here. So this is how you would write a 4M. Now, another system has been developed so that we can tell somebody, for example, let's say you're doing a distance test and the person doesn't see the urine, or the person's basically giving you the number over the phone, or you want to make a mental note of it and you want to make sure that it's written down so you can remember it, because we want this number to get down to a 4M as the person is restoring their energy. We don't want to have a lot of cloudiness and a tremendous amount of particles in there for too long of a time. So we've developed, Dr. Manthe, Dr. Beto, and Dr. Reams have developed a plus system. Okay, so for example, with the 4M, there are particles floating around, but most of the specimen was clear. A 4M plus, and this is how it's described, there's more debris than normal, but not quite as much as to begin to affect the eyesight through the specimen. So what's that mean? What that means is you look through the specimen, and it's not really affecting your eyes in any way. You can see clearly through it. Now this one is close to being a 4M plus or a plus plus. But if it does start to, there's a lot of particles in here, but it's not affecting your eyesight, then that's going to be a 4M plus, because it had quite a bit more. And I know that sounds a little bit arbitrary, but when you learn the higher plus ones, you'll begin to understand the difference between them. The next, so let's say that you had that situation. You have more debris than a 4M, but it's not enough to affect your eyesight. What you would do then is you would mark that as a 4M plus. Let me make my M a little bit more like an M. There we go. A 4M plus. Now, if you going to go to a 4M plus plus, what happens is that you're going to use your pipette as a reference point. And what happens is this is going to help you to see whether it's affecting your eyesight or not. Because what happens is you put it against the wall, and the particles in the urine specimen, if they are starting to affect that eyesight there, and which this one is a little bit, then you know that that's going to be a 4M plus plus. If there was just more particles like the last time, but it wasn't affecting your pipette, wasn't making it a little bit foggy or anything, then it would just be a 4M plus. But if it is starting to affect the eyesight, then you're going to have a 4M plus plus. Again, these two right here, these two, the 4M plus and the 4M plus plus, are the most arbitrary of the 5 possibilities you have when you're doing this albumin reading. And of course there are other readings that could be below 4M. That's rare, but it does happen at times. I've had a few of them. Okay, the next reading up is going to be a 4M plus plus. Now this is very straightforward. If you can take the pipette and you put it to the back wall of the far end of the glass, as I have it here, and you look through the cup and you cannot see the pipette, that is a 4M triple plus. Okay? However, if you can bring it to the middle of the glass and see the pipette, you know that it's not a 4M quadruple plus. Alright, so you have it here, you see it see it in the middle, but you don't see it at the edge, far edge. That is a 4M 1, 2, 3 plus. And you write it just like that. Probably a lot neater than I write it, but that's the idea. And the final quadruple plus is if you take the pipette and you put it in and you're looking right through it, and you put that pipette directly in the middle of the glass, and as you're looking through the urine, you cannot see that pipette in the middle of the glass, that is a 4N quadruple plus. That person has a tremendous amount of dead cells coming out. Tremendous calcium deficiency. And it's a good thing that person's there to see you, for you to help them. And that is essentially how we do the 4M. The albumin reading. I just would like to give you the formulas. If you ever wanted to do this 4M, do the albumin out complete. Well, let me first do this. Let's write it on the card. If you were to do we said this was a 4M double plus, so you would write the 4M, and you would put the 2 pluses just like that. So this is what we have for an equation so far on the 21st of April 2009 at 3 o'clock. You notice I use military time. It's easier for me. You use whatever you want. 3.3 sugar, 6.3 urine pH, 7.3 saliva pH, a 13.7 sea salt, and we have a 4M++ albumin reading. Now again, I wanted to take the albumin and show you the formula essentially is this. It's the number, in fact I have it right here. I think you can, let's see if you can read it. There are two formulas for it. I would like to show them to you. Formula number one is you take the number of particles in the urine, you multiply it by 1,000, milliliters. You then divide, this is a division sign, the volume of the specimen in milliliters times 20,000, and you divide that number by, and then that's going to be divided by the volume of the specimen in milliliters times 20,000 divided by 1 million. So let me put that formula down here for you. So for example, let's say we had 200 particles in the specimen. And then you would multiply that by 1,000. And then that would be over you'd have that over the volume of the specimen in milliliters times 20,000. Divided by the volume of the specimen in milliliters times 20,000 divided by 1 million equals M. Okay, you take the number of particles in the urine times 1,000 milliliters divided by the volume of the specimen in milliliters times 20,000, and then you divide the whole thing by 1 million. So you have to set it up as two division problems. You know what I'm going to do? I'm going to just give you the problem number, the second one. It's much easier. Much easier. Let's just do that. It's going to be the number of particles. So let's say you had 20. And it's going to be times 20, and then it's going to be divided by the volume of the specimen in milliliters. Let's say you had 200 milliliters. That's much easier than doing all this other work. So 20 times 20 would be 400. And then you would divide that by 200 because that was your milliliters. So 400 divided by 200, that's real easy to figure. It's 2. And that would be a 2M. So again, let me show you that formula. If we could get a clean piece of paper here. I just want to give you that. I'm going to have somebody get me a clear piece of paper. I'm sorry, I have it right here. I have it right here. So what we want to do is take the number of particles, and you're going to multiply that times 20, and then you're going to divide that number by the volume of the specimen. And so, you're going to divide that number by the volume of the specimen. Okay, number of particles in the specimen, if you saw 10 times 20, that would be 200. Then you divide that by the volume of the specimen, that will give you the M number. So again, 10 times 20, you'd have 200. If your specimen was 50 milliliters, that would be 50 into 200, be 4M. If it was, let's say you had number of particles was 10, you multiplied it by 20. But let's say the specimen was 200. Then what you would have would be 200 divided by 200, and you'd end up with a 1, and it would be a 1m. Okay? So that should be pretty simple to do, but you don't really need to do that except in very special cases. The best thing to use is the plus system that we learned earlier, and you should be okay. And that takes care of the albumin lesson. Thank you.